extract review 2 to your GIS folder. Open the review 2 APRX and review the 00 Basics GeoDatabase. All right, so when you opened up the review, you were shown something like this. This is basically how it opened, correct? In catalog. So one thing I want to point out here is that when it says review the 00 Basics GeoDatabase, you should know that that is not the default geodatabase. It's not going to be located here because databases, right, are either databases that are imported into the project or the default GDB. If you can't find the GDB, you should automatically go to folders and review the folders here, and that's where you're going to find your 00 Basics. Okay? So, in the contents pane, you would select 00 Basics GDB, and you see essentially this, right? And the first question is, examine the raster LC87091 and answer the following question. How many rows are in the raster? Well, we've gone through this question probably 3 times this class, right? What you need to do is you need to right-click, go to Properties, and review the raster properties. This can be done either in the geodatabase or in the map, all right, or in a map. I've been showing you the last few times in the geodatabase, and since this APRX, this project opened up in the geodatabase, that is a relevant location to look. You right-click, you go to the properties, and you see right here, there are 2,354 rows. All right, any questions on that? Next question is columns. Right above that is 1,370 columns. The third question, what is the cell size? Now it's telling you right here, that is 30. Now, it didn't ask you cell size in units because the next question was raster map units. And you know that to answer that question, you need to go down to spatial reference and identify the linear unit, which is meters. The next question is, what is the raster projection? That is right here, right? And this was a multiple choice. So you didn't have the option just to put in Albers, right? But you did have the choice of Albers Parn, NAD 83 units meters. And that was the correct answer. Okay. Any questions on any of that? All right, this is the real basic part. The last question, or not the last question, but the next question is how many classes are represented in the raster, right? Don't get thrown off by looking up here. There's somewhere in here it says classes somewhere. No, don't worry about it. Don't get thrown off by looking at properties. When it says classes, right, what you want to do is you want to come over here with the raster selected to the table and just count the number of rows. 1, 2, 3, 4, 5. There are 5 classes in this raster. Okay? And then the next question, raster class values. How many pixels assigned to each? That can also be answered here. And the values 26,983, 114,727, 27,176, and 1666. All right. All of you, I would expect, I hope, if you see similar questions, should get all of those right. Those are low-hanging fruit, okay? All right. The next question, again, something we've gone over many times in this class. Change detection. Navigate to the toolboxes in catalog. Okay? Toolboxes in catalog right here. And create a new model in the Review 02 TBX. Create a new model. Right click, new model. As soon as you do that, the model pane or model view opens. Okay? And it says, once the model opens, select the View tab on the ribbon and select Catalog pane. View, Catalog pane. All right. Open folders. Open folders. Review 2. 00 basics. The 00 basics GDB. And add the 2 rasters provided in the geodatabase to your blank model. And you can just drag them over. We have LC87091 and we have LC03091. We all know that the LC87 represents the 1987 land cover and the 03 represents the 2003 land cover. Okay? Using the appropriate tools from Analysis tab on ribbon, Geoprocessing pane toolboxes, create a model to combine the 2 raster layers in such a way as to create an output that will allow you to determine land cover change between 87 and 2003, and then answer the following questions. So before we do that, what we need to do is, as it discussed, we need to open the toolbox from the analysis pane. So you go to Analysis Tools. You could also do that just in Geoprocessing and Tools. I will navigate to these by just going to the toolboxes instead of searching, but you can always search for these tools, right? But bottom line is, with change detection, it is a process of multiplying the first year and adding the second year, right? So we know, if we're back here in catalog, and we look at our folders again, we know that based on our 1987, we have values of 0, 1, 3, 4, 5. When we multiply these values, you're going to end up with one cell of 0. 0 times 10 is 0. All right? 26,983 values of 10. 114,727 values of 30, right? And so forth and so on. Because this is the first year, right? Change detection. That will be added to these values. 1, 3, 4, and 5, right? 0 plus, so if we look at 1, 3, 4, and 5, right? If there is a 0, it will be 1, 0, 1. I don't think there is, but I can't recall. But we should have values of 1, 1, right? 1, 3, 1, 4, 1, 5. We should have values of 3, 1, 3, 3, 3, 4, 3, 5. The point I'm making here is examine your input data. When you examine your input data and then compare it to the output, it should make sense. What you are doing is you're multiplying the first year and adding it to the second year, okay? So, jumping back to our model, we know to do this, we have to come down to our Spatial Analyst tools, search for our, here it is, math, add the times tool, put it up next to 87, because that's the first year. Connect 87 to times. It's going to be our our input raster. Our model times, our tool is still gray. What does that mean? It means it needs another parameter, so we need to double click on that. And we know our input raster value, because change detection requires this, our constant value is going to be 10, okay? It's not telling you what to name the output here, so I'm just gonna keep the default. I'm gonna select OK. I'm going to come back here to Model Builder just so we can see it better and go to Auto Layout. And we can see that if we hover over our constant value, it is 10 times the LC87 raster, and this is our output. As I said, these values should range between 0 and whatever 50 or whatever it was. And those need to be added plus our 0.3. So our output is going to feed into the plus tool. Input constant value 1. And we're going to add that to the 2003 data. Input raster value 2. Just to verify everything looks right, double click on the tool. And sure enough, we can see the input value is the output of the times plus the LC03 raster. We can call this change detection or whatever, change detection. And it's like, okay, whatever, again, there's no naming. So auto layout, you can validate just to make sure everything looks good. Right click on change detection, add to display, and run. All right, actually, since I have my viewshed open, I didn't need to add display because this was supposed to be done in catalog, but I will just remove this so we can look at it in catalog. Because I have my viewshed open here, right? It added it to display, but we don't want to look at that there. We want to look at it here. So in review 02 GDB, right? Because this is our default GDB. This is where everything is saved, right? All of our output is saved in the default GDB. It's not going to be saved in the 00 basics, right? It's going to be saved in our review 2 GDB. Keep that in mind when you're doing your practical. All output is saved in the default GDB. All right, so change detection is our output, and we see, sure enough, there is that one value of 1, right? And then the rest range from 11 to 55, right? The first digit is the first year, 1, 3, 4, and 5. The second digit is the second year, 1, 3, 4, and 5. So it makes sense that we have values between 11 and 55. You can now look at this attribute table and answer the following questions. How much forested, 4, became urban, 1? We simply look at 4-1, and we know the answer is 1375. How much non-forested, 3, became urban, 1? Same thing, we look at the value 3-1, and the answer is 28032. And then finally, the trick question, how much water, 5, was once urban, 1? How much water was once, 5 is the second digit, 1 is the first digit, so the value, the answer is 247. All right, any questions on any of that?
get to it again? I can't
How'd I get to what?
Under the geodatabase, you said it was under the default.
These,
The change detection output, yeah.
well, the output was developed here,
Mhm.
okay? All output